Hello students, today I am going to discuss about very nice topic, that is your tangent and normal. This topic belongs to your chapter application of derivative. So now we are going to discuss about the main four or three part. Basically we are going to discuss about concept concept of tangent and normal. Secondly, we are going to discuss about your slope of tangent, and equation of tangent. And lastly, we are going to discuss about your slope of normal and equation of normal. So these three portion we will cover in this lecture. Okay, so what is the basic meaning for tangent and normal? First we have to know, okay, tangent and normal. So first you can see there is a one curve like that way. Let us take, this is your continuous curve, okay, continuous curve, and for this curve you can draw one tangent, like that way, and this intersect point is called, that is your point of contact, so that point actually, that is intersect between the curve and the straight line. Basically this is your one straight line, that is your, that is your straight line, and this line is called your tangent, okay, that is a touching point, that is your point of contact, only single point touching point, okay, so that is called your point of contact. Let us take your P. So this line is your called tangent. And similarly, when the line in any other line which is perpendicular to that tangent, so that is your 90 degree, if any other line which is perpendicular to that tangent at point of contact, same point of contact, then that line is called your normal. Very interesting. So this normal also is your any straight line, okay. So look at this diagram. So this line is called tangent, and perpendicular line on a tangent at point of contact is called your normal. So these two lines, tangent and normal, these two lines are perpendicular to each other and they are at their point of contact. You can write tangent line is perpendicular. This symbol is called your perpendicular to normal line at which point? At point of contact. So what do you mean by point of contact? Basically that point where the curve, and this is your, let us take y equal to fx curve, the curve and the line intersect each other at a single point. That point is called your point of contact. So this is a basic concept for tangent and normal. Tangent line is perpendicular to normal line and at point of contact. So you can note, please. Okay, so now whenever you go for find the slope of tangent and equation of tangent, as well as slope of normal and equation of normal, so you have to know, that is straight line chapter topic, that very conceptual, the straight line topic. Okay, cut. Okay, so next, now we are going to discuss about slope of tangent and equation of tangent. So we are discussing slope of tangent and equation of tangent. So for this topic, whenever you go for this topic, so you have to know regarding your straight line. So first of all, I review the straight line topic. Straight line topic. Okay, so you have to know the equation of straight line. So I have to review that. That is already studied in your class 11. So in your straight line, because actually this tangent and normal both are straight line. So that straight line means you have to know the equation of straight line. How you have to write your equation of straight line, how you have to find your slope of straight line, you have to know. So what is the review? Number one, you have to know equation of straight line. Equation of straight line. Straight line. That is point slope form. Point slope form. That is y minus y1 is equal to m into x minus x1. Very important form. Here this x1 and y1, this x1 y1 is your passing point, and m is equal to slope of line, and you know that slope of line represented by also tan theta. So look at this. If I any straight line passing some point x1 y1 and slope, let us take anti-clockwise angle is theta. The slope of line is your tan theta. Let us take m is your slope. M is equal to slope of a line, and that represent m is equal to tan theta. That also used here. Okay, so this form you have to know. Y minus y1 is equal to m into x minus x1. Okay, where x1 y1 is your passing point, this is your passing point, and this m is equal to slope of line, which is represented by tan theta. You know the what you meaning by slope of line. Okay, so later on I will again discuss whenever I will go in or discuss straight line. Okay, so next review is number 2, that is if two lines perpendicular each other, then their product of slope m1 into m2 is equal to -1. Okay, if two lines are perpendicular each other, let us take L1 line, let us take L2 line, they are perpendicular each other. For this slope is m1, for first line m1, second line slope is m2. If that happens, then what is the condition? m1 into m2 is equal to -1, you have to know. And comes to your third, if two lines are parallel each other, two straight lines parallel to each other, then m1 is equal to m2. If two lines parallel each other, let us take L1 and L2. If two lines are parallel each other, then their slopes are equal. So very important for these three. Next, number 4 is if two curves are at right angles position, two curves are at right angle position, then they are called orthogonal curves. Okay, so what do you mean by this? That is, if you draw like that way, if there are two curves, let us take like that, and this is your tangent lines, and another curve like that way. Let us take this curve, okay, and this is point of contact like that. Okay, so if these two tangent line perpendicular each other, then you can say that these two curves are orthogonal. That means tangent line of curve number 1, curve 1 is perpendicular to tangent line tangent line of curve number 2 at point of contact. Point of contact means here two curves intersecting at points, so intersecting point. Intersecting point, okay. So you can see that there are two curves intersecting some point. Let us take P, and you can draw the tangent at P for curve number 1. Let us take, this is curve 1, this is curve 2. And first of all, you have to draw the tangent at P for curve 1. Similarly, you can draw the tangent line for curve number 2 at same point P. If two lines are perpendicular each other, so then you can say that these two curves are orthogonal curve. Okay, you have to know that point also. Okay, next, number 5 review is if the line parallel to x-axis, then the slope of line is equal to 0. If you see like that diagram, this is your x-axis, origin, y-axis. If the line parallel to x-axis, their slope is 0 because their angle, these two are parallel means no angle formed. If theta is 0 means then 0 is 0. Later I discuss regarding slope also. Okay, just you have to note please that line parallel to x-axis, then the slope of line is equal to 0. Here m is equal to 0. So next, number 6, if the line parallel to y-axis, then here also then slope of line m is equal to infinity. You can see the diagram also. If the line parallel to y-axis, this is your x-axis, y-axis, parallel to y-axis means the angle is your pi by 2, and that case you know that tan pi by 2 is equal to infinity. You know that slope of line is tan theta. Theta here is pi by 2. That's why tan pi by 2 is equal to infinity. So that slope is equal to infinity. Similar way, if you check here also, theta is your 0 degree because both are coincident or parallel. Theta 0, and you know that if theta 0, tan 0 is equal to 0. So that slope here is 0 and here is infinity. Okay. Number 7. Okay, so regarding slope I am discussing. Let's see slope. What do you mean by slope of a line? Let's see. Slope of, you have to know also. Again, I repeat here, slope of a line. Okay, so slope of a line means, first of all, look at this x-axis and y-axis. X-axis and y-axis. And there are any line you can draw like that way, either passing origin or other line, no matter. So just follow the line, and that line, look at that line. Let us take L line. Look at this L line. This line makes some angle with positive x-axis in anti-clockwise direction. Anti-clockwise direction, you can take theta. Okay. So this theta is your angle, and whenever it comes to your tan form, this theta operation is tan theta, so that is called tangent form. Okay, so that is called your slope of a line. Okay, so how much angle make between your line and positive x-axis in anti-clockwise direction, so that angle with represented by tan form, that is your slope of a line. M is equal to tan theta. Okay, tangent theta. Okay, so next if look at this, the line, look at this, that line. Okay, so that line, look at this, the line, so that line makes an angle with positive x-axis in anti-clockwise direction is your, let us take theta. In that situation, slope also m tan theta, tangent. But here this angle is your greater than 90, so that this slope is called your negative slope. Okay, and here is this angle is your less than 90 degrees, so that this slope is called your positive slope. So you can remember also this concept. Okay, that concept already you've done in your straight line chapter. Still I revise this topic. Okay. Next. So next, now review is done. So you know that there are 7 topics you have to know for solve the equation of tangent, slope of tangent. Okay. So now comes to your slope of tangent. Slope of tangent. Okay. So first of all, slope of tangent we can represent by derivative of y equal to fx function. You know the derivative. Actually, what is the geometric meaning of derivative? That is, you know the derivative means slope of tangent. You know geometrical approach, slope of tangent, that is called derivative of yx, y equal to fx some point. Okay, so derivative of yx represented by, you know that f dash x at some point, x equal to some point, p point, let us take p point x1 y1. You can take also, let us take x1 y1, p point x1 y1. Okay, so that is your slope. Let us take, this is your m. M means slope of tangent. That is your dy dx. Dy dx means derivative of y function with respect to x. So whenever you find the slope of tangent, there you can see now the curve is given, y equal to fx is given. So from that equation you have to find slope of tangent, means you have to find your derivative of y with respect to x. If the function is y equal to fx, that is your slope of tangent. That formula is very important. You can write here m is equal to dy dx equal to f dash it at some point p. So this is your slope of tangent. You can note this. Okay, now comes to your equation of tangent line at some point p. Let us take x1 y1. Okay, so how you have to find your equation of tangent? You know that point slope form from straight line. I already reviewed that. The straight line called, that is say y minus y1 equal to m into x minus x1. So you know that point slope form. So here look at that case diagram. Let us take p is your x1 y1. Okay, so now your requirement is you have to find the equation of tangent line at particular point of contact x1 and y1. So you can write here equation of tangent y minus y1 is equal to, you know that slope of tangent. That is represented by dy dx at particular point. Here particular point is your x1 comma y1 into x minus x1. So this is your equation of tangent line at p x1 comma y1 at p point. Okay, next. Now we are going to discuss about your slope of normal. Slope of normal. And what do you mean by normal line? You know that normal line is perpendicular to your tangent line. Okay, so you know that normal line is perpendicular to tangent line at their point of contact at p. Okay, at same point p. That means you know the straight line form. If two lines are perpendicular each other, so you know that condition, their slopes is equal to, product of slope is equal to -1. You know already, you know that form. Okay, so now you know that if I take the tangent line slope is m1, slope for tangent line is m1, and if you take m2 is your slope of normal line, and you also know that slope of tangent line is equal to represent by dy dx at particular point x1 y1, that is your m1. Just substitute here, so you can know. So from that expression you find out that is m2 is equal to -1 by m1, and you can find m2 is equal to -1 by m1, means here you can substitute here dy dx at particular point x1 y1. This is your slope of normal. This represents your slope of normal. Whenever you find slope of normal, you can use that form, that is your -1 by dy dx at the point x1 comma y1. Okay, now you have to find out that equation of normal line. How you have to find what is your equation of normal line? So you know that point slope form, that is you already know from straight line y minus y1 equal to slope into x minus x1. Okay, so here m means slope of normal line, and you know that slope of normal is 1 by dy dx at the point particular x1 y1. So that value you can substitute here. You got the value equation, or you can find your equation of normal, that is y minus y1 is equal to, it means here 1 by dy dx at the point x1 comma y1 into x minus x1. So this represent the equation of normal line. Okay, now comes to one very important nice question, that is example. Look at this very easy example, that is find slope and equation of tangent of y equal to fx. The function is given and particular point is given. So for that particular point you have to find the slope of tangent as well as equation of tangent you have to find. Okay, so you know that whenever you find the slope of tangent, your slope of tangent, you know that form is dy dx at particular point P. So here P is your 1, 2. So first of all, you have to derivative this function. You know that y is equal to x cube plus 2x, means from that function dy dx is equal to, so what is the derivative of x cube? You know that 3x square plus what is the derivative of 2x, then constant in outside, and what is the derivative of x? That is your 1. That means you got the value 3x square plus 2. So this is your derivative. And now you can put here, so slope of tangent is 3x square plus 2 at particular point 1, 2. At particular point is 1, 2. So that means here 1 means x coordinate x, y coordinate is y. You can put here x value is 1. So that means you got the value 3 into 1 square plus 2. That means 3 ones are 3 plus 2 is equal to 5. So you got the value slope of tangent. This is your slope of tangent solution. Now comes to your equation of tangent. You know that equation of tangent represent by, y minus y1 is equal to derivative at particular point into x minus x1. So here this particular point is x1 y1. Here x1 is 1, here x2, and y1 is equal to 2. So that value you can substitute here. So this y1 replaced by 2, y minus 2 is equal to, now you know already slope of tangent, you know that is your 5 into x minus, you know x1 value is 1, x minus x1. Just simplification, you got the equation of tangent line. So y minus 2 is equal to 5x is a 5x, 5 ones are 5, minus 5. So finally you got the solution equation of tangent, that is y, or you can write like that way, 5x minus y minus 3 is equal to 0. If you simplify that expression, 5x plus y here is minus y, then plus 2 minus 5 plus 2 is your minus 3. So this is your equation of tangent line, 5x minus y minus 3 equal to 0, and the slope of tangent is equal to 5. Note please. Comes to another question regarding your slope and equation of normal. You have to find the slope of normal as well as equation of normal. So how you have to find? Let's see. You know that slope of normal is equal to minus 1 by dy dx at particular point P, and here particular point is P is equal to 1 minus 1, 3. So that we have to find first of all dy dx. So here given function is y equal to 3x4 minus 2. So that means dy dx is equal to, in derivative 3 outside, and x4 derivative is your 4x cube minus constant derivative is 0. So that you got 12, 4 is a 12x cube. So dy dx is equal to 12x cube. Now you can substitute here, that is minus 1 by 12x cube at particular point P, that is your minus 1, 3. So here x value 1, minus 1, and y value 3. So that means you have to substitute here, x value is minus 1. So you got 1 by 12 into minus 1 whole cube. So that you got 1 by 12, that is your slope of a normal. That is your solution. Slope of normal is equal to 1 by 12. Okay, next. Now you have to find the equation of normal. So you know that how we have to find equation of normal line, that is y minus y1 is equal to minus 1 by dy dx at particular point P, x minus x1. So now here passing point, here a point of contact P is your -1 comma that means this is your x1 comma y1. Here x1 represented by -1, x1 is equal to -1 and y1 is equal to 3, y1 is equal to 3. So from that expression you can substitute here y minus y1, y1 means 3 is equal to, you know that slope of normal, is 1 by 12 is equal to into x minus, x1 value, that is your -1, bracket close. So you got the value y minus 3 equal to 1 by 12 minus plus x plus 1. Next cross multiply. So you got 12y minus 36 equal to x plus 1. So finally you got the value x minus 12y then plus 37 is equal to 0. Okay, so if I minus 36 comes to here plus 36, that is 36 plus 1 is your 37. So you got the value x minus 12y plus 37 equal to 0. So this is your equation of normal line. Okay, so note this and thank you students. Next class again we'll discuss.